Hello everyone and welcome to the Vectric 2020 user group meeting. My name is Navrik Baines and joining me today will be my colleagues Charlotte Pullin and David Phillips. We will be representing the support function of Vectric software. Today we thought it would be a great idea to go through 10 things that we wish we had known when we first started in C and C. Now I appreciate that many of you are returning users and are Vectric wizards, very experienced with our software and C, but many people will be joining us for the first time today and potentially will be new users to C as well as to our software. So we thought it'd be a great way to teach you some tips and tricks that helped us out when we first started in C and C. Today we will be discussing the following topics. I will be covering understanding the material boundary within our software, as well as understanding how we model 3D models within our software and how to get around some of the tricky parts of toolpathing 3D models. Then we will move on to Charlotte Pullin, who will be going through the differences between the composite model and preview simulation model within our software, efficient machining, as well as efficient 3D machining. And then finally, David will be presenting the overview of the vector validator and the content sources on our website, such as the Vectric free projects, the Michael Tyler and partner projects, the D&M website, so this is the design and make website where you can download and purchase any clip art, the overview of the Vectric portal, as well as an overview of our tutorial page. We do look forward to your feedback and please have any comments and questions ready for the end of the presentation, and we do hope you enjoy and find this very, very useful. And without further delay, we will now move on to our first presentation. Welcome everyone to the first part of our presentation today. I'll be covering understanding the material boundaries within our software. So when I first started with CNC machining, often a question that would come up a lot, both from myself and other customers, was where do I set my Z0 position? So let's just look at our job setup sheet over here for the moment. So we've got a double-sided job. I'm actually going to Z0 off the material surface for the purpose of this demonstration, and I will be using a 3D model later, which is why I have this very high resolution over here. So let's just close out this menu for the moment. Okay, so I've got this diagram over here just to help demonstrate some of the differences between the material surface and the machine bed when using your Z0 position. So in an ideal world where you know you've got a block of wood represented by this square over here, where the top of the surface is flat and the bottom of the material is also flat, you can actually Z0 off of the material surface or the machine bed in this scenario because you still get an accurate cut depth. You could also use material surface if you were to use any engraving toolpaths as well, but you may encounter some scenarios where the top of your surface is not flat. So you may encounter something like this, perhaps not as exaggerated as this material here, but this is just for demonstration purposes. Now what's the danger with this? Well, what can happen here is you can get an inaccurate cut for one, but also if you have a rapid Z movement with your tool and it runs into material, like for example this peak here where I did not expect material to be there, you could actually end up damaging your tool, damaging the material, and getting a rough cut overall. Similarly, you could end up just cutting air, quote unquote, where the tool expects material to be, but unfortunately there is no material here, as you can see in this valley here. So what would you do in this scenario? Well, what you can do is a couple of things. You could set your Z0 off the machine bed, or if you wanted a flat surface to work with, you could actually rough away this material and get a nice flat surface to work with. And I thought I'd just quickly demonstrate how you could do that. So as you can see here, I've got this square vector around my job sheet. Now I've purposely made it bigger than my job sheet because in this scenario, I'm going to be using a pocket toolpath to rough away the top of my material here. And I've made it bigger than my worksheet because I want it to be going over the top of the material and just over the edge of the material as well to make sure I get rid of the majority of the surface. So let's just go ahead and go to our toolpath menu. So we're going to choose a pocket toolpath over here. We're going to go down by 0.2 inches and I'm going to choose a raster on this one. So let's just go ahead and calculate. And as you can see here, this is the toolpath that we will be running, and this is where I'll be cutting away some of that surface. Now, important thing to note here, in the software, it's not going to show that jagged edge as I showed on the top of the material, because the software will show the material as a flat piece of wood. But for argument's sake, let's just say it's there, and we're going to be getting rid of it in a moment. So I'm just going to go ahead and preview this toolpath. I'm just going to stop this toolpath in the middle here just because I want to demonstrate the difference in the top surface now and the new surface that we have here where we've removed material. Now I wanted to point this out because occasionally we will get support tickets come in that will say, hello, I've got a toolpath but it's actually cutting air. And often the scenario will be where they have a first toolpath that actually roughs away the majority of the surface here. So for example, if they had a 3D relief, and that roughs away the majority of the material at the top here to get some of the detail on the relief. And then they'll go to do a pocket toolpath and a profile toolpath afterwards to cut out the whole piece. And what will happen is, because they've roughed away the majority of the material on top, when their pocket toolpath goes to cut, or their profile toolpath is actually cutting where the material used to be on the surface, because they haven't taken into account that the surface is actually now a bit lower because they've roughed away the majority of the material. So I thought it'd just be an important thing to note just while I have this animation open. Now I did mention 3D reliefs, so I'll be using one today actually to demonstrate why material boundaries are also very important within our software. So I'm just going to reset this preview and I'm just going to delete these toolpaths for the moment. Okay, now we're back in the modeling tab and we're actually going to go ahead and import a 3D component. So I'm just going to go to the tutorial files where there's an excellent tutorial that Becky has made. Here we are, and this, some of you may recognize this. This is actually the two-sided marlin from the two-sided machine tutorial that Becky has on the website. And if any of you are interested in further detail regarding two-sided machining or this project, we will leave a link in the description below for you. So let me just set up this job. Okay, now that we've set up our 3D model, as you can see over here, this is the surface of the model. So this is the top side of the model. So we can just go ahead and flip to the bottom over here. Here we are, and this is the bottom of our model. Now let's just go ahead and put on the x-axis so you can see what's going on here. So this is our top. Now right now you can see that this is the top of the plane here. However, this doesn't really tell you much in regards to where this model is currently sitting within our software. So a great tool you can actually use, and I wanted to demonstrate in this presentation, was the Draw Material Block tool, which is under the View option. And if you go to Draw Material Block, now this is excellent because this helps you understand your material boundary in so many great ways, in that now you can see where your model is currently sitting in your material block. And as you can see here, this is so helpful because we often get tickets saying, hey Nav, I've got a flat spot on top of my 3D model. Why is that? Or, you know, I've taken into account all the depths and everything else. Why have I still got these flat spots on my model? And often the case is because the model has hit the material boundary here. And this is just a great tool to help you understand where your model currently sits in this material. Now, if you're wondering how you can adjust the height for this, or if you can adjust the thickness of your model, what you can actually do is you can go over here and right click on your model. You can go to properties and you can actually adjust the shape height here. So let's just zoom in a little bit to allow you to see what's going on here. So if I adjust the shape height, you'll see, there we are. And you can see now it protrudes slightly from the top of the material surface, which isn't going to be great, but we can adjust that later in our software. So let's just go ahead and adjust the base height as well. And again, as you can see, this actually adds a base underneath the model here that allows you to raise the height of the model within our material. But for now, I'm going to reset these changes and I'm going to go back and I'm going to show you another way you can actually look at the material boundary and use a useful tool within our software to help you place your model in the right place and understand what you are working with. So let's just go to our toolpath menu. Now under material setup, you have this button here called set. So let's just click that for the moment. And we'll show a detailed summary on the toolpath tab. So what we're going to do here is, you can see here we've got this slider and it says model position in material. So right now what we can do is, you can see this lighter part of the material, and this is actually indicating where our model is. So if we just go ahead and drag the slider down, you'll see some changes reflected over here in our 3D view. Here we are, and now you can see the model has been placed further into the material block. Now this is really helpful in that if you have a very thick model, or if you wanted to raise the base height of your model but also didn't want to hit these edges and still wanted to make the most of your material, you can just use this slider over here in the material setup sheet to get your ideal project and cut depth. Now I hope this has been helpful, but I've covered some very in-depth material in a very short space of time. So we'll leave some useful links that will go over more of this material in the description below for you, and please do not hesitate to ask any questions or leave any comments. We always welcome the feedback and we're happy to interact with you after this presentation. And we look forward to seeing you in the next one. Hello everyone, and welcome back to the second part of my presentation today, where I'll be covering 3D models and how they're represented within our software. As you can see over here, we have an image of some pin art or a pin board, and you may be thinking, well, what does this have to do with 3D modeling within Vectric software? Well, it's actually to do with the fact that we use pixels to represent our models within our software. So we use a tightly knit bed of thousands, if not millions of pixels at once to represent a smooth, skin-like surface for our models, which allows for high resolution, high detailed models at a very low hardware cost. So what do I mean by hardware cost? Well, when you first start CNC machining, you have to buy a CNC machine if you don't have access to one, that is. You'll also have to buy some form of CAD software, for example, like we have Aspire or VCarve Pro. And then potentially, depending on the software, you may have to buy a very high-end PC or a high-end graphics card. But that's not the case with our software. The software does a lot of the legwork for you because of the way it uses pixels, and it allows for very high resolution models with a very low hardware cost. So that means that even if you were a very experienced user of CNC machining, or even if you were new to it or a hobbyist, you could still use our software to do very high, accurate, detailed modeling. So I thought it'd be a great way to explain this further by using a model within our software to explain some of the intricacies around 3D modeling and maybe some of the issues that you may encounter and how you can get around them. So let's just turn off this layer for our bitmap over here, and we're just going to go over to our clip art tab. And I'm just going to click into clip art, and we're just going to go down into objects and people. And for this demonstration, I'm actually going to use a wizard. So I'm just going to scroll down until we get to our wizard. And here we are, and I'm just going to drag, just left click and drag into our job sheet over here. Let's just center them a little bit. There we go. So here we have our wizard. So we're just going to go over now to the modeling tab, and we're going to have a look at raising the height on this a little bit. So let's go over to our 3D view. Okay, so here's our wizard. As you can see at the moment, it's quite flat. So I'm just going to go ahead and raise the height a little bit. But I'm also going to, if you remember from the last presentation, turn on my material block so I can see where this is currently sitting in my material block. So I'm just going to right click on the wizard model over here, go down to properties, and I'm just going to raise the base height and the shape height just a little bit for this model. So I'm just going to go up very slightly on this one to about 0.5, and I'm just going to raise the base height to about 0.3. In fact, I will just type it in now. Now already you can see a problem that we may encounter, and many of you may have encountered this, and any of you who are new to 3D modeling, this is something to look out for. So if we just zoom in over here, as you can see over here, we've got some pixelation on the edge here, or a jagged edge, and often we'll get support tickets where customers will ask, how come I'm getting a jagged edge on my 3D models, and is there a way I can eliminate this? Well, actually there is a way you can get around this, and it's actually within Aspire. But don't worry, I'll be going over some methodologies for our other software too if you do not own Aspire. But for Aspire users, what you can do is if you can click this model, and you can go over to this option over here called Create a Component from Visible Model with a draft added. Now a draft is essentially just an angled edge, but that will help get rid of some of this jaggedness around the edge here. So for this example, I'm just going to go ahead and change this to 26 degrees, and I'm just going to go ahead and hit apply. And there we are. Now you can see there's a smooth angled edge on this wizard here that eliminates some of that jaggedness and helps you get a nice smooth finish. Just to reiterate though, I'm just going to go over to the 2D view and show you that this is actually a different component. So if we just double click on this model here and just move this out of the way, this is the original wizard that I had, and this is actually a new component created with a draft edge. So it's just important to note when you're working with 3D modeling and any layers. So I'm just going to get rid of that for now because I want to demonstrate to those who don't have Aspire how you can get around some of the issues that you may have with jagged edges. And that's actually going to be using 2D toolpaths. So what you can do in this scenario is you've got your wizard over here, you can just click on him now, and in this option you can go ahead and click create vector boundary around selected components. Now this will effectively create a vector around the edge of this wizard, and what we can do then is if we just click that, and I'll just demonstrate for you where this boundary sits. I'm just going to click our model again. I'm just going to move this out of the way. And here we are. You can see the boundary here now. You can see this very clearly in our software. So what you can do now is, if we just move that wizard back, if we go to our toolpath menu, I'm just going to click the boundary edge over here. There we are, and there it is highlighted. And now what you can actually do is create a profile toolpath to run down the edge of your model and create a nice smooth finish around this model here for you as well. And that's one way you can get around some of the jaggedness that you may encounter with 3D modeling and some of the pixelation that we have down the edges of the sides here, because that comes up often in support tickets. Now it's important to note that again I have covered a lot of in-depth topics today in a very small amount of time. So again, we will leave some useful links in the description below for you, labelled in regards to which presentation they are representing, and please do not hesitate to ask any questions or leave any comments. We really do value your feedback, so I look forward to hearing from you. And now I'll now pass over to my colleague Charlotte Pullen, who will go into further detail regarding 3D machining, and I do hope you enjoyed the rest of this presentation. Thank you kindly.
Thank you very much for that, Nav. I just wanted to add in one extra little point about this, which is a related one. So we have, as you were saying, the modeling resolution to control the quality of the 3D models. We also have the preview simulation quality, which controls the quality of the toolpath simulations at the end of your designing. Now, these are, again, going from standard all the way to maximum. The standard preview will be the roughest, but will generate more quickly and allow you to get quick previews of your designs, whereas the maximum quality will obviously run slower but give you a much nicer, sharper, cleaner look to it, even though they're all based on the same square pixel technology. So you would want to use the first to create a quick image while you're designing your work, so that you can just quickly whoop, there we go. But as you can see on closer inspection, you can see the pixel jagged edges there, as you did before in Nav's previous demonstration. But if you wanted to, for example, to get a much more sharper and cleaner look to, say, present to a client, you can just increase the resolution here. It will reset the preview for you, and then you can just preview them again. It will take a lot longer to run at these high resolutions, but as you can see here, the jagged edges are a lot more higher resolution, so that way they don't stand out nearly as much, and you can get a much cleaner look to the final preview. When you then use this on a 3D toolpath as well, it can really help it stand out and pop to make it look really good for screenshots to show to your customers. I'm now going to move on to my next topic. We are going to be looking at some methods for efficient machining, and one of the common pitfalls we find that some customers will stumble into when they start using the software. Now, there are many online resource sites for STL files, 3D models, which are quick and easy to download. And people will sometimes want to just grab one of these files, pull it into the software and create toolpathing for it very quickly and efficiently. This is a prime example of this. Now, as you can see here, the design is really just a few flat areas. There's no actual 3D in this. It's just a bunch of pocket and profile toolpaths waiting to happen. But what people will do is, as I will demonstrate now, so they'll open up a new design, create it as the sort of size they want it to be, and then they'll just go to import a 3D model, for example this one that I've got here, and then you know, as normal, you set it to the correct size, correct the zero plane position so it's sitting exactly where you want it to be. And there we go, we have a 3D model waiting and raring and waiting to go. And then people will just want to quickly put a profile, sorry, and then people will just want to create a roughing toolpath, which they can quickly run, so calculate a quick toolpath, And as you can see, it will cut all over the model, including some of these flat areas at the top which don't actually require any cutting. So the cutter will spend a lot of time dancing over the wood, not really achieving much. And then they'll then continue on with a finishing toolpath, again in a similar vein. And then this will just be a common 3D toolpath to show you what this looks like. And I'll quickly run it through on the preview at a low resolution so that we can see that in action. So let's put that down to standard. And all of these toolpaths together will produce something a little bit like this. You can see there's some elements which don't translate well to a 3D toolpath and then don't get cut because of it. And there's not really much we can do about that, unfortunately. And overall, this toolpath is going to take quite a long time to actually process. Instead, what you want to do is look at the design and see where you can get away with using a 2D toolpath wherever possible. In this case, it's the whole design, because we can actually, we close this down now, and I'll bring in a copy of a 2D vector of the same design here. As you can see here, it's a nice group of vectors, which we can just ungroup. And this is exactly the same design. And you look at it and you say, well, okay, so I want this bit here pocketed out, so I'll grab those. And if I go over to the pocket toolpath, I can now go, right, well, I want my end mills to cut this so I get a nice flat, smooth bottom to it. And again, just calculate that. And here we go. It'll be much more efficient than the previous one. And then same again, if we go back to this, grab these circles as well, and then we can just apply a profile toolpath to cut out the rest of the design. In this case, we want to cut all the way through the material. So we'll set that to the 1 inch with Z equals. And we'll use the same tool that finished the pocketing as well. Cutting outside the line. We should add some tabs, but just to move things along, I'm going to skip those. See some more of our tutorial videos for more details on the best way to set up profiles. And now we can just go in, preview all of our toolpaths again, and as you can see, it's much quicker and gets all of the details we want, and also works well with the material thickness that we're going to be using. So that way you can then achieve a quick and efficient toolpath using just a few 2D toolpaths in place of trying to use the 3D toolpathing. It requires a little bit of planning ahead, but overall will save you a lot of time on the machining side of things, and also give you a much cleaner looking finish. For my third presentation, I want to now talk about using some efficient toolpathing with a design which does require 3D toolpathing as part of its construction. But again, as mentioned before, with an aim to limit it to only the 3D elements and using 2D toolpathing where applicable to get a better, cleaner, faster result. Now for this one I'm using the round pillbox from Design and Make. Here you can see this design has got a curved outer side, a 3D element in the middle, and while you can't quite see it here, this is actually a domed center, so that there is a 3D element all of this, with the exception of this outer line here. Now to work on this, we've already got it downloaded here on the software, the round pillbox. And I'm just going to import some parts and get this set up ready for the next stage. Now I've imported the 3D part, we're going to now set up a few vectors to help us produce and carve this item. So as you can see here, we have a sloped edge to the part, 2 scallops on the side, a lip around the middle, and then a large empty pocket in the middle. The first thing I tend to do when starting working on a 3D item is to add a vector boundary. This allows me to work with the option here in the roughing toolpath you'll see here, the selected vectors. This allows me to direct the 3D toolpathing to only areas I want it to cut. Now, as it is at the moment, this is still more than I would like to cut right now, but as you can see here, it'll just calculate for a second. And here you see in the preview, it's going to cut a large section out of the middle and then only a little bit around the edge. This is quite a long toolpath simply for this section, and it doesn't even manage to achieve the around edge that we really want. So we can work on this by including more of a boundary offset, as that will cause the 3D toolpath to step outside of the boundary and keep cutting further and further. However, we want to have a bit more control over this, so that the 3D toolpath does not waste time in the central area or around this inner lip, which is best cut with a pocket. So what we're going to do, we shall first of all create a circle to be our pocket for the center. So we'll snap to the middle and drag it out until it's the right size. And there we go, that is going to be our pocket toolpath when we get to it. Next we're going to create an inner lip vector, so that we can then cut this lip out with another pocket toolpath. And finally we're going to then add in an extra vector around the outside, which will act as a larger boundary so that our bit can fit down the side and cut this steep edge for us. So we have our 3 vectors all lined up here, and now we're going to apply a number of toolpaths to help us get this cut out as desired. So the first thing we shall do is cut a pocket toolpath with this first circle. The depth for this cut we can check by going into the 3D model, hovering our mouse over the area that it's going to cut down to, and checking down in the bottom right hand corner where we can see the Z value, which is currently set at minus 0.2066. So if we create a toolpath with a cut depth equal to that, so 2066, and we're going to use a standard end mill since we're just cutting out a circle. And we just click calculate and we'll have our first cut. Next we want to then select the inner circle and we'll then create another pocket toolpath. Since we were already cutting that away on the first one, we can now copy that, put that in as a start depth, and then what we can do is check the bottom value again, so that is minus 1.0327, and we'll put that in as the cut depth to give us our final cut. There we go. So this will start this toolpath slightly further down into the area that's already been cut. There we go, and we can just click calculate. So if we reset this toolpath and check the pocket 1 and check pocket 2, we have now created the inside of our pillbox using these 2 pocket toolpaths. Next, what we can now do is, if we go back to our 2D view and open up our 3D roughing toolpath, we can now select this vector here, which is going to be the inside of our 3D cut area, and then we can select the outermost vector as the outside of the boundary and remove the boundary offset, as we have already designed these vectors to include this offset that is required. So we can click calculate, and as you can now see, the final toolpath will now cut down the side of the part for us along this slope and leave us ready for a suitable finishing toolpath to follow up. For a more in-depth video on this subject, you can check out our efficient machining of 3D parts with the Rose and Crown sign, where it will guide you through the whole process from start to finish. And now I shall leave you there with my colleague David, who will be talking about the vector validator.
Thanks, Charlie. One topic we see raised frequently by users on support is working out why vector files they've imported into our software will not toolpath correctly, because they either contain multiple vectors which overlap and intersect each other, or open vectors where they should be closed. It's something that I definitely wished I had a better understanding of when I first started, because until you know why these problems occur, it can be quite frustrating, and it takes a lot of time away from your creative process. Here you can see some examples of common queries relating to vector issues, and I'm going to cover the various methods you can utilise to overcome these problems. First of all, it helps to know what you were dealing with, so I'm just going to give a very brief overview of what vector graphics are and how they are used to create toolpaths. Vectors are essentially a visual representation of mathematical coordinates, which contain in their basic form a start point, an end point, and a direction of travel. This creates a numerical map for CNC software to plot the direction of travel for your machine tool, and anything that interferes with this map, such as another vector crossing its path or a break in what's intended to be a complete contour, can interfere with the way the software interprets the vectors for toolpathing. It's also useful to know that the reason you can't use bitmap raster graphics to create toolpaths is because it's essentially colour information laid out in a pixel grid, and they lack the coordinates required to create this map. Just as a quick demonstration of how to correctly close an open vector when you encounter one, we'll use this arc, which is currently an open vector, because it has separate start and end points. So if you select these 2 points together and right click, you'll see this option in the drop down to close vectors, and there are 3 different options: with a line, with a smooth curve, or by moving the endpoints together. And shown here are the 3 different results that you'd get. So with a straight line, with a smooth curve, or by moving those 2 endpoints together. But all 3 create a closed vector. A situation where vector problems can be most apparent is where you're working with an imported file which has been created in third-party software. So this DXF file was created in Illustrator, so I'll just demonstrate what happens when I try to apply a pocket toolpath to this cocktail glass. So as you can see, this dialog box is telling me that that's in fact an open vector, even though it looks at first glance to be closed. A really quick and effective way to locate potential problems within an imported file is the vector validator. This is a really useful tool as it will automatically search and locate zero length spans, overlaps, and intersections. There's also a VCarve mode option to direct the tool to look for potential problems specific to this strategy. So if we go ahead and click Search Selected, the tool will highlight the potential problems and mark them with a corresponding symbol. If we then zoom in on one of the intersections marked by the plus symbols, you'll see a fairly typical intersection that can occur with imported files. So in this case, you can use the interactive trim tool to remove the excess spans and join them at the intersection point. So let's try and run the pocket toolpath on that cocktail glass again. And as you can see, that's now worked. So that's confirmed that that's now a closed vector. This is an example of another common point of confusion with vectors. Here the user is trying to create a slot with rounded edges by joining 2 circles together using the Join Vectors tool. So this shows what he was trying to do, and I've also set this up to demonstrate the difference between grouped and join vectors. So if I click on any span here, you can see that all the vectors light up together, which might make you think that they're actually joined, but watch what happens if I try and apply a toolpath to that. You get a message telling you that there's still an open vector, and that's because you can't join an open vector, such as a line, to a closed vector. So one way of turning this slot shape into a complete closed vector would be to delete the inside of these 2 circles. So I've just flipped that into node editing mode. Then delete these spans. And also these lines, which aren't joined to the circles. Then if you select the 2 corresponding nodes together, from the drop down list, first select join vectors with a line, and then for the next 2 you can see that join vectors is greyed out, because once we've connected those 2 points it will create a closed vector. So if you select closed vectors with a line, that will create that slot shape as one complete closed vector. So we try and apply the pocket toolpath again. You can see that it now works. One last thing that I wanted to cover quickly in this section is how to convert text into vectors. So this can be especially useful if you're working with joined up text and there are areas of overlap that you need to clean up by using node editing. So here we have some true type text, so all you'd need to do is right click and go down to convert to curves, and then that will convert the text into vector information. I hope you found some of the points I've covered in this section useful, and now I'm going to move on to talking about some of the content sources that really helped me when I started. So you've heard us talk about some of the things that we wish we'd known when we started in CNC, but you might be wondering how you access this information. Well, one of the great benefits of being part of the Vectric community is the wealth of information you can draw upon to hone your skills from the content available both through the website and also through your V&Co accounts. So I'm just going to give a quick run through of what you'll find when you log into your portals. At the top you'll find links to all your available software downloads, so they're now easily accessible from the top of the page, including your purchase clip art, and also a link to Designer Make where you can purchase additional clip art. Underneath this there's a gallery of projects and user case studies to give you inspiration if you're stuck for something to do, with links to various content pages related to these. Further down you can access the Vectric forum, so you can benefit from some of the vast knowledge and generosity of other forum users here. So I'd recommend that you give this a look. And down at the bottom are our social feeds, so you can keep up to date with all things Vectric. So we'll start with having a look at the training video section. So if we just click on that link underneath the software downloads, and on the page you'll see various tutorial categories, so you can either choose to view the videos under these more general links or take a more tailored learning strategy and have a look at the process related videos under the different headers. So once you've found one, if you click on the play button, you'll get the video player within the window here, and also underneath you'll find the tutorial files available for download so you can follow along with the tutorials. We also have available from this inspiration gallery projects made by our Vectric partners. So you can go here to see some really innovative ideas, and they've even made the project files available to download yourselves, so hopefully we'll see some of you giving these a go. So if you click on the individual projects, there's a bit of a background of the making of the projects here, and you can also download the project files from this button here. As well as this, we also have a project uploaded each month from Michael Tyler, so be sure to check back regularly so you don't miss out on some of these fantastic projects. And again, these are all available for you to try yourself, and they also include a complete walkthrough of the project from start to finish. I'm now just going to show you how you can access over 2,000 individual clip art files for you to purchase and download through Designer Make. So from the download section of the portal, if you click purchase clip art, this will redirect you to the Designer Make website. From the home page you can search all model projects which combine individual pieces of clip art to create a full project, all individual clip art pieces, or you can choose this option to view everything within Designer Make. So as you can see, you've got different categories down here, so you can narrow your search terms if you're looking for particular types of clip art. And I'll just show you quickly how you'd go about purchasing and downloading. So once you've found a file that you're looking to purchase, on the next page you'll be able to see previews of the file. And if you scroll down to the bottom, click add to cart, and then before you check out, if you click on view cart, this drop down box here, you'll be able to choose your file type before you proceed. So you can choose from these 3 file types. Once you've done that, if you click check out now, you'll be able to either sign up or sign into your account and proceed to the payment. All of your purchase clip art will then be available to download on your VCarve account from the download your clip art button. And that brings us to the end of our session from the support team, so thank you for joining us. We hope you found some of the topics covered useful if you're at the start of your journey in CNC. We'll be available after the session ends to answer any questions, so if you'd like to stick around for a chat, then please use the comment section to contact us. Thanks again for watching, and we hope to see you all again very soon.